If I were to talk to you today about how the messaging around climate is actually happening, something is missing. Either we are being too aggressive, messaging is being passive aggressive. I think somewhere we need to strike a balance. The conversations, they need to be more meaningful. They also need to be more lucid. Your thoughts around that?
If you were to actually go ahead and read through a research paper, what you'll find is that the language, yes, can get very, very passive aggressive, as you mentioned, right? There may be certain papers where the predictions aren't looking too good. They will not undermine that or understate that or overstate it. But when you look at the people, the middle people who are taking those research papers and simplifying them down for the general public, I'm talking about the news media. What you often find is that the news media either have to choose two polar opposites. They either have to choose it's going to cause all this harm, or maybe we shouldn't really look at climate change as big of an issue. You see how the news media takes a viewpoint made in a scientific research paper and opinionizes into these two polar opposites. That's where the division lies. And I feel like we as people, as the general public, should be aware.
There is no climate justice without economic justice. Because what really happens is when a climate emergency happens, it's not people like you and me who have enough resources or enough support, but it's the people who are not economically well off, people who are living by seashores or places where they bear the brunt. And unless we come up with solutions which actually helps and affects everyone around, we will truly not be able to come up with or provide climate justice.
I feel like climate justice requires economic justice, or more specifically, social justice as well. Consumption is inherently correlated to GDP. How do you detach those two metrics from each other?
Climate change is real, but so is our power to change it. Take action today.
Look for the silver lining whenever a cloud appears in the blue.
Hello and welcome to Between Us. Make every conversation count. As I always say, Between Us is about conversations that matter, conversations that we have with ourselves. And one of the most important conversation that we need to have and that I have is about our planet, is about sustainability. It's about living a healthy life, not just for ourselves, but for people around the world. Today, we begin the first of three-part series on climate and sustainability. And I have a young voice on the first episode of the climate series, Rudra Sekhri. Rudra is a Bachelor of Science in Physics. He's minoring in mathematics. He has dreams of creating a wholesome, sustainable planet. He's excited about astronomy. He pursues physics. He pursues climate. He loves to produce music. He loves reading books and many more. So I look forward to this exciting episode with Rudra Sekhri. Rudra, thank you for being on the show. So Rudra, talk to me about your growing up years.
For me, I was born in India, and when I was at the age of 2, my family decided to move to Australia for work-related reasons. So growing up here in Australia, it's sort of, the Australian, you get the Western, habits and lifestyles, and you start to adopt those. So in the house, I used to. My mum used to teach me from a very young age. So my mum used to teach me basic maths, basic English, and all that type of stuff. And as I got older and older, my dad would often teach complex mathematics and would often teach physics for me as well. I find life in Australia to be extremely peaceful, unlike in many other countries. I know for India, I go to India once every year or two, and the fun that I have in India is that everything is so fast-paced, right? Because you have a lot of people, there's so much to do. And maybe it's just me because I'm an outsider and I come to India for one reason, and that is to meet relatives and to explore India and to explore our culture. And I feel like the time that we spend there is a bit too little and everything feels fast paced. But I just generally feel that in Australia, everything is a lot more slow paced and a lot more, as we like to describe it, chill, very
Mhm.
relaxed. It's a very relaxed nature here in Australia.
Your parents were born and raised in India. Which part of India do you travel to?
So whenever we go to India, we always go to our home state, which is Haryana. So my parents both are from Haryana. I myself was also born in Haryana, and we and again, as I mentioned, the reason why we go there is primarily for one reason, which is to meet our relatives. But a secondary, more important, and a purpose that I find more important is to actually explore our ancient culture and history and all that type of stuff, which I find extremely fascinating. Every time. In fact, recently we went to India and we went to very, very famous places. It's often because of that, inherent history and culture that's present there. So we went to UP, specifically Mathura. So we went there. That was very, very, very fun. And we went to a multitude of different places just to really expose ourselves to that history. Because the thing in Australia is that while Australia is very multicultural, you can learn a lot about other cultures from other countries. For example, from Vietnam, from Thailand, and so on and so forth. You can experience the food, you can experience the festivals. In what I find in Australia is that that energy you get from knowing your own culture and celebrating your own culture. For example, celebrating Diwali, celebrating Holi. It's not the same as what you get in India or wherever you're from. So I just tend to find that whenever we go to India, that level of experience is on a whole nother level compared to what we find in Australia.
You're right. It's really different when you actually come back home. I completely understand that feeling when you actually come back and celebrate it. It's very different. You did mention about mathematics. You mentioned about physics. Your primary early teachers being your parents, and I know what you do right now, especially your interests, which centers around astronomy, which centers around climate. At Between Us, we are about stories, we are about conversations, and as we always say, the most important conversation is the one we tell ourselves. In a post-pandemic world, all of us across the globe got an opportunity to really look within ourselves, do a lot of introspection, self-reflection, and we also got an opportunity to ask ourselves who we are. But it also gave us an opportunity to realize that we do not live in isolation anymore. No problem and no challenges belong to an individual or belong to a nation. It belongs to all of us, humanity. And when you reached out to me to be a part of the podcast, what really attracted me about your profile was the fact that you are passionate about something which I'm passionate about, but you're also passionate about something which affects all of humanity. I feel each one of us are climate leaders in our own right. It,
Exactly.
it could be a homemaker in a remote part of India, Africa, anywhere. When we work towards leading a sustainable life, we are leaders. I want to break this conversation into two or three parts. One being the idea of climate change, the science behind it, because you do a lot of research. I want to talk about what is it that we need to do for the youth who are global citizens. I know that you are an astronomy buff, and apart from that, you have a lot more interests, and we'll try to see how much we can explore. We have a tradition at Between Us where we say, let's begin from the beginning. So let's begin from where your interests around climate, your passion
Yeah.
towards making a difference begin.
Well, thank you for the compliments. My focus right now, before I get into where I started, my focus right now has always been to educate people on why exactly do we know what we know about climate? How exactly do we know that we as humans are influencing the world around us? That is sort of my purpose, and that is what I feel like I've been working towards over the past few months. Now, where I started was sort of more of that solution-based, as you mentioned, that solution-based approach. And back in the day, I was in Australia, we referred to middle school as primary school. So back then, primary school, imagine me or really any student as a third or fourth grade student. My parents, and specifically my dad, really wanted me to go down the route of learning to program at a very young age. So learning how to code computers, and learning all sorts of different languages. So that's actually where I started. And the reason why I'm saying that I had a solution-based approach when I first joined this sort of, this area of, solving local sustainability problems is because of the fact that the applications for technology in modern day solutions is incredible. There are innumerable solutions for current local sustainability problems using technology. It's just a matter of which technology do we use and to what limit do we use that technology, because too much technology is also bad as well.
Why do you say too much technology is also bad?
So the reason why is because, as we all know, to produce anything such as the laptop that I'm using or the microphone that you have right there requires some level of material production. And any material production has associated carbon dioxide emissions. This is precisely why I'm a bit hesitant when it comes to particular solutions around the climate, such as electric vehicles, because if you were to really think about how much carbon emissions are being emitted as a result of that material production for EVs, it's actually slightly more than current petrol cars over the course of their entire usage. So that's why I sort of like to look at material production, look at how much energy is being used, because the amount of energy that we use is actually correlated to how much CO2 or greenhouse gases we emit. So that's why I'm suggesting that too much technology is also bad. Sometimes there's also just redundant technology in a solution that's just unnecessary. So it's really about creating a solution where technology is being used, but it's being used to achieve a very specific purpose without too much redundancy. And in the case of myself, back then I was learning how to code, and I was learning how to apply those coding skills to local sustainability solutions. Nowadays, since for the last 2 or 3 years, I've been the one actually helping students in the local community achieve that same process. And to be able to really teach those students, you really need to know what can be easily educated to those students? What can you easily teach to those students? Because it's not just about this is a perfect solution, but it's going to require all these complex technologies. No, we want to engage students as well. And so that's why there's this, for me, I'm trying to, I've been working on this area as well. So that's where I started. And after learning more and more coding skills, and after learning many, many, many different technologies, such as the Raspberry Pi, which is a very, very, very good example, the Arduino, the BBC micro:bit, and all their extensions, I've been working with the local government to help educate other students, but also implement those solutions within the community. And those solutions don't have to be incredibly complicated. I mean, certain solutions can be very simple, but the idea is that those solutions can be taught to others, and those students and those people can then create their own versions, and those get implemented, and it's sort of like a chain effect, and that spreads throughout the community. That's what I believe is a truly sustainable solution, a solution where everyone is getting involved in the solution itself. Everyone is teaching each other. And it's improving that community engagement, but it's also fixing a problem in sustainability within our current community. A solution that I would recommend right now to any listeners is find out someone who's good at gardening, right? In your local community. Start a local community garden. For that matter, you should start running sessions within your local community. Get other people to know what it feels like to make your own food, to make your own produce. Start making that in your garden. These local community gardens will reduce our emissions, our transportation emissions that we produce because of the transportation of food. And this local food production also improves self-reliance, something that a lot of countries are starting to take notice of, especially India with recent situations around the world.
If I were to talk to you today about how the messaging around climate is actually happening, I feel that somewhere something is missing. Either we are being too aggressive, messaging is being passive aggressive. I feel there is a disconnect. I feel the way the messaging is happening. And I feel that in many ways also is off-putting for people who really want to understand what it is. I think somewhere we need to strike a balance. The conversations, they need to be more meaningful. They also need to be more lucid. Your thoughts around that?
Yeah, so I feel like any discussion on climate change falls under three broad camps, right? So I myself fall into the last camp, which I'll mention at the very end. But the first camp that many people know of is the doomism camp. Oh, climate change is going to affect us in the next 10 years, and there's nothing we can do to stop it no matter what. They're somewhat true. They're not entirely true. They're somewhat true. Then you've got the next camp, which understates the crisis that we are experiencing. So those are the people who say, well, sometimes predictions can be wrong. Maybe these climate predictions may be wrong as well. Who knows? We're not going to take these at face value. Hence, we're not going to really care about this issue as much as others. Second camp. The third camp, and I personally fall under this camp, is somewhere in between. We like to say that, yes, climate change is an extremely important and urgent issue, but at the same time, we need to be optimistic about solutions. It's not like we're not making progress. It's just that, at least in my opinion, I feel like we're making progress in the wrong places. And I'll explain my thought process on that in just a minute. So with these three camps, a lot of these, some people within these three camps are what I like to call extremists. They stick to their views very, very, very permanently. And in the third camp, it's a little bit more flexible because everyone is sort of appreciative of, both sides of the argument. But for the first two camps, there is a lot of people who stick to that viewpoint. And I feel like that's a bad way to go about things. And as you mentioned, conversations are the way to get action, are the ways to get positive change out. So when we look at the third camp is really the camp where everyone should be in. And a lot of scientists are actually in that third camp. And the reason why is because if you were to actually go ahead and read through a research paper, what you'll find is that the language, yes, can get very, very passive aggressive, as you mentioned, right? There may be certain papers where the predictions by those scientists, according to their climate models, aren't looking too good. And they will call that out. They will not undermine that or understate that or overstate it. But when you look at the middle people who are taking those research papers and simplifying them down for the general public, I'm talking about the news media. What you often find is that the news media either have to choose two polar opposites. They either have to choose climate change is going to change the world and it's going to cause all this harm and it's total doom and everything, or maybe we shouldn't really look at climate change as big of an issue. You see how the news media takes this opinion, or, well, not necessarily an opinion, but a viewpoint made in a scientific research paper based on the results provided, and opinionates it into these two polar opposites, into these first two camps. That's where the division lies. And I feel like we as people, as the general public, should be aware that scientists actually fall into the third camp. We should be aware that the media is for the sake of their own, for their own business, are trying to essentially sensationalize certain scientific content to make it more engaging for the audience. And to be fair, that is partially true and it's partially understandable as well. Because as scientific communicators, our job is to make science engaging for others, for the general public. But we cannot make it engaging unless we sensationalize a little bit of what is being said in those papers. That is often why you find that clickbait in scientific communication is such a big issue. And I feel like podcasts, number one, certain news media outlets that are willing to be honest and are willing to actually provide sources, or three, directly from the research paper, those three sources of information are generally speaking very, very, very typically unbiased. And they tend to fall into that third camp when it comes to climate conversation or conversation for any matter on any topic. I feel like when people think about climate change, they immediately think about the politics of it. And that's not a good way to think about a scientific issue. Remember, climate change is inherently scientific. The research that we're doing is inherently scientific. It's just that the issue has become so politicized and so polarized that we've reached a stage where no one on both extremes is willing to talk to each other on it. And I feel like all of us need to really think about, is climate change really as bad as people say it is? Yes, for the most part. If you read what the paper states, yes, it is fairly bad as of right now. But does that mean that there are no solutions? No. There are absolutely plenty of solutions, and we'll get to those later if you decide to. So I feel like everyone needs to reconsider their current viewpoint and really try to get an unbiased view of the whole issue.
When you start defining stakeholders, the most important stakeholders are the people, right? It's not just the research scientists, the politicians, or the institution. When you don't talk to your consumers, and it's not just about climate, it's about anything. When you don't talk directly to your consumers, to the people who's getting affected by it, when you're not having that conversation, you will always go back to the drawing board. I feel somewhere laying out these stakeholders, I think the people who are ultimately going to be the beneficiary of the solutions, or the people who are actually bearing those challenges, we don't include them at the end of the day. We feel that sitting in a conference room somewhere, debating and discussing will really help. I don't think it helps. I think when we talk about someone facing an existential crisis in some parts of Africa or India, in some remote places, if we don't include them in those conversations, don't understand from them the real challenges they face, any solutions which come out, any amount of research is important, by far, very important. But I think we need to make sure that those people for whom you are drawing out those solutions, they need to be engaged, and we need to engage with them constantly.
What we should do is to really consider what exactly is it that we need, not what we want, what do we need? If we just shift our mindset from wants to needs, that will automatically reduce half of our consumerism, half of our consumption. And right now, if you look at the world's state today, you'll find that the majority of CO2 emissions are correlated, meaning they form a very nice relationship with the amount of consumption. And unfortunately, consumption is essentially what we're measuring when we measure GDP. So it's a very sad thing to say this, but if we want to reduce consumption, that is naturally going to have an impact on GDP. And so for all the people who are saying, look, we want to come up with good solutions, but that are also good for the economy, you really have to consider, well, how are you going to detach or get rid of this correlation between consumption and CO2 emissions? That's the big question that I feel like a lot of policymakers and a lot of, stakeholders in companies aren't really asking. They're not asking, number one, how is this going to affect people who don't necessarily live in our local areas, who may not be directly affected by our company's decisions, but may live somewhere halfway across the planet in some part in Sri Lanka? How is our decision going to have an effect on them? There's this funny show for those who are interested in watching, run by the state news corporation called the Australian Broadcasting Corporation, and that show is called War on Waste. I actually was extremely grateful to meet the host of War on Waste. He was initially a comedian, but then became a climate activist. And what he did was, I'm sure you've heard of McDonald's and the straws, the plastic straws that they used to produce. He brought in a turtle made of McDonald's plastic straws into a McDonald's office center, right? In a workplace, in a McDonald's workplace where all the business people and executive people live. And he brought that turtle in, and he said, "Well, what are you going to do about this turtle?" Because to be fair, McDonald's plastic straws were having an impact on turtle populations. And they had to kick him out of the workplace because of, his stunt. Now, whether people call that pathetic or not, that's up to them in their opinions. But what this really shows is it really shows this inherent ignorance around a company's decisions on the entire globe. And that's something that we've really, really, really got to acknowledge. And as you mentioned, the best way to do that is to have a platform where the company can talk directly with the climate activists, the climate advocates. And we're finally seeing that change come about in Australia, where we're now seeing a reduction in the amount of plastic bag usage. We're seeing a reduction in the amount of plastic straws that we used to use. And we're seeing a reduction in the amount of plastic waste that's actually being produced in Australia. It's small steps, it's baby steps, but eventually the hope is that there will be government control over this, government policies to make sure that we're really getting this waste issue down pat. And
I think that's a valid point. People will have to learn to make those choices. Government can be a facilitator, they can act as an enabler, but it's for each one of us to realize, these small decisions we take, how much it would help, not just for us, but for the many generations to come. I want to talk about right now the kind of technologies which scientists and climate solution providers, the kind of technology they're using right now.
so I guess I'll start with the most obvious ones, which we've all heard of. Electric vehicles, we've heard of this coming already, and it's actually happening a lot in Western countries. A lot of people are adopting electric vehicles. But if you recall back earlier in the episode, I mentioned how electric vehicles from a consumption standpoint isn't as much better as petrol cars. What I would suggest is other solutions. For example, nowadays in Melbourne, if you were to go to Melbourne, there are certain roads where before you could actually see cars going by along those city roads. Nowadays, those roads are completely blocked, meaning no cars can go through. And instead, those are now walking spaces and spaces for other forms of transport, such as electric bikes and electric scooters to take over. I feel like that's the solution. Electric vehicles, sure, great. But at the same time, consumption-wise, they're maybe not the best. Another better alternative is electric scooters, electric bikes. These solutions will allow you to travel vast distances, but they are much more carbon, they emit much less carbon compared to electric vehicles in terms of a consumption standpoint. And this has already been implemented in Melbourne. Again, some other solutions that I'll mention briefly but are not actually technological before I go to some others. Number one, just plant more trees, and specifically plant trees near pavement. And the reason why I'm stating that is because concrete, for some of you who may not know, concrete is an excellent absorber of heat. So when light from the sun comes and hits down on the earth, concrete is incredibly good at absorbing that energy. We don't want that because that actually warms up the planet. And you will often hear this referred to as the urban heat island effect. And this is actually a part of global warming, which humans are causing. And this is especially a problem in cities. And so what you'll often find in cities such as Melbourne is local governments are working extremely hard to plant more trees to increase tree cover so that concrete doesn't absorb as much energy as before, reducing the urban heat island effect. There's now even cases of technological solutions where people are growing cyanobacteria, a special form of bacteria that can absorb CO2, into these water tanks and placing these water tanks throughout the city. And these water tanks are being used as benches because you can just add a bench to the side of the container. And it's just an excellent view because it looks really green. It's very nice, and it's very nicely constructed. And I think there's trials in Europe for this kind of technology. What I find is that a lot of solutions don't necessarily have to be technical or technological for that matter. In fact, I would argue that some solutions anyone could do, right? Starting from now. So whenever you go to the grocery store to get groceries, right, you would often have your groceries in a plastic bag. You would take those plastic bags home. And maybe if you were eco-conscious, you would reuse those elastic bags so that they would be, so that they wouldn't be trashed immediately after, you bought them and used them. And that's actually now government policy in Victoria, the state that I'm a part of. So according to the state government, you can no longer use single-use plastic bags. They have to be reusable. And so now a lot of companies actually charge you for those reusable plastic bags because now they've just found another way to make some money. So it's another solution that we're seeing is the introduction of more and more conservation, especially around rivers. And that's because a lot of the water that we get that rains so when it rains we get a lot of water, and the concrete doesn't allow that water to get absorbed into the soil. So that storm water is what we refer it to gets filtered down the drains, and those drains eventually discard them into rivers and into lakes and so on and so forth. And the problem now that's emerging in Australia particularly is that a lot of rivers are becoming what we call permanently flowing rivers. And the reason why we call them permanently flowing is because before these rivers never used to be they never used to flow all year round. Sometimes they would dry up and sometimes they would fill up with water. But now they're becoming permanently flowing rivers. In other words, they are flowing 365 days in a year because of our stormwater that we are discarding. So a solution to that is install rainwater tanks. And more specifically, a good technological addition to that is installing smart rainwater tanks. And these smart rainwater tanks will have this little Arduino or little piece of technology that essentially tells you, number one, how much water do you have in your stormwater tank, in your rainwater tank? Number one. Number two, it can give you a weather forecast. So this is the weather that's going to happen in the next 5 days. And number three, it could give you recommendations based on the weather forecast and maybe a machine learning model or even just a simple algorithm, right, developed by students. It's not too hard to implement. And these suggestions could be use this much water by then because on this day there will be this much water that you can collect. And that will essentially reduce the amount of, and if everyone implements this in their own household, this will reduce the amount of stormwater that is just sort of getting drained by the concrete into these rivers. And that will help conserve the local biodiversity that's actually within the river itself. There's a lot of local government policy that happens in these areas. And there's actually sustainability departments present within local governments in Melbourne to ensure that, these areas are well maintained. And there's even separate committees. I'll give you an example, the Darebin Creek Management Committee. And the whole mission is to just manage one of the many rivers in Melbourne, the Darebin Creek in this case.
In fact, one of the things which I truly believe in, I keep sharing this on multiple platforms, even on a couple of other podcasts I've recorded, that truly, there is no climate justice without economic justice. Because what really happens is when a climate emergency happens, it's not people like you and me who have enough resources or enough support, but it's the people who are at, people who are not economically well off, people who are living by seashores or places where they bear the brunt. And unless we come up with solutions which actually helps and affects everyone around, we will truly not be able to, come up with or provide climate justice.
Exactly.
We no longer live in isolation. And just as the problems are global, and I know that some of these problems are local and you have to address them locally, but in general, most of the problems and challenges we face are global. And
Yeah.
we need to have solutions which are focused to your local areas. At the same time, we must realize that the solutions must involve everyone from the community. It's not just because the more inequality we have in our society, the more difficult it will be for us to provide solutions, right?
Yeah, I'll add one or two things to that. I feel like, and I feel I have a lot of discussions with other people, especially my best friend who's also a climate advocate as well, and we're best friends from high school, so it's natural for us to talk about this in our free time. But I often talk to him about this and talk about sort of this idea that you mentioned, which is that climate justice requires economic justice, or more specifically, social justice as well. And he goes on to mention a lot of fascinating ideas around this. And I mentioned one previously, namely that consumption is inherently correlated to GDP. How do you detach those two metrics from each other? And I'll go one further for you today. I feel like we as first world citizens, people in developed countries, do not understand how our actions in our households, or as a country as a whole, is having an impact on people in, say, the Maldives or in Sri Lanka or in Bangladesh, right? I was recently reading a research paper in which they mentioned that the effects of global warming, if they were to continue, would result in the Maldives becoming uninhabitable by 2050. And that's not due to the Maldives going underwater, but it's just the increase in wave-driven flooding making the Maldives uninhabitable. And you sort of have to really ask yourself, really ask yourself, what is it that I can do to really reduce my personal carbon footprint, right? And we as first world citizens, we form the top 1 to 10 to top 10% or top 20% for that matter of the world in terms of economics and all those metrics. And if I was to give you some rough metrics to work with, the top 10 or 20% of the world actually produces the majority of carbon emissions. And even if you look historically as well, the majority of carbon emissions historically have come from countries where their times of industrial revolution happened around the 1850s or 1860s. So I'm talking most of Europe, America, and all these first world countries that we think of today. And this is why I often find the position of certain first world citizens a bit perplexing, because they often state that China's most responsible right now for CO2 emissions. But if you really look at it, I feel like a better metric to look at is the CO2 emissions per person. So how much CO2 is each person emitting in a specific country? And yes, while China emits lots of CO2 emissions per person, they are nowhere close compared to first world countries like us in Australia, in the USA, I once again see this correlation, and I think, how do we detach ourselves from it? How do we, as first world citizens, actually take our consumption and our consumption practices and everything, and reduce it, and reduce the amount of CO2 we produce as a result of it?
That's very well put. All right. So we spoke about strategies around reducing carbon footprints. We spoke about reducing waste. We also spoke a little bit about conserving natural resources.
Yes.
Let's talk about what you're doing right now with the local governments.
Yeah. So I guess that brings us full circle to finishing off one of the first questions, which was on sort of my journey. And once again, I'm extremely grateful to be on this podcast and be able to share that journey, not just with you, but to potential students who might actually be interested and inspired. So continuing from where I last left off, I started, again, as I mentioned, on the solution-based approach to climate change. And I worked on a multitude of projects with local government officers, and I've led many student groups within that were organized by the local government to address these solutions. So one of the projects that I'll mention is the water quality monitoring system, which was actually presented at the statewide stormwater conference, which is a conference all about, as you guessed it, stormwater, and all the wonderful positive and negative effects of stormwater on the local community. And I had the honor to work with a couple of university students as well on the project. And essentially the whole idea is that monitor the water quality, more specifically monitor sort of the presence of certain chemicals within that water, monitor the pH, monitor all these different parameters that could affect the local ecosystem, because we felt that a lot of the local industry dumps a lot of their waste into these rivers, and there sort of needs to be a constant monitoring of that to protect the local species that are present there, especially platypuses. And I'll give you some data on that. So we know of, so in Melbourne, there are really three main rivers that we got to know about. The first one is the Yarra River that passes through the center of Melbourne. And then you've got the Darebin Creek, and this creek feeds into the Yarra River. So it's a small river that eventually feeds into the Yarra River. And then you've got the Plenty River, which is a completely separate one. What we find is that in the Plenty River and in the Yarra River, we find that there are lots of platypuses there. But we find that in the Darebin Creek, there's not as many. And that's a problem. And that's probably because of local biodiversity issues, namely the fact that the water flow rate is way too fast. And there's a lot of other issues like pollution, etc. So to address these issues, not just in the Darebin Creek, but also in the Plenty River as well, because those problems are also present there, we developed this basically like this giant sensor that essentially just that gets dumped into the water and essentially monitors for certain parameters like the temperature, the pH, the conductivity to measure how much metal is actually present within the water itself, and a bunch of other parameters as well to measure how cloudy the water is, how translucent it is, so on and so forth. And these massive sensors, if you will, are completely self-operated, meaning that they work on solar panels. They send their data up to the cloud, and we can essentially collect that data through a bunch of solutions such as APIs and other processes, so on and so forth.
Are they live now?
So they are live. We've got about 5 that are deployed in the local community as of now, and we're working with local students within high schools that live around the Darebin Creek and the Plenty River, so that they can actually collect that data and use it for their own purposes as well. And we've been experimenting with a bunch of different processes for how to collect that data and use it for our own purposes.
As of now, do you have some data to go with? Do you have?
So as of now, from what I currently I do not, unfortunately, but I will be able, if you want, I can supply some data as well if anyone is actually interested.
this could be replicated on a multitude of other solutions which we're looking
Exactly.
at. So if you're looking at a solution for reusability, the solution in itself should be reusable, right? So,
Precisely. And
yeah.
so that's the whole idea. So we installed 5 sensors throughout the Plenty River, so at different locations. And essentially that will, if there's a drain that's in between 2 sensors, we will notice that, shift in water quality very, very easily. And we can, and in theory, you could use that data to then be able to, track, okay, which industries are responsible for draining waste into those drains, and then call them out for it if you wanted to. And that's what we want. We want students to be at the forefront of this development, working with the local government to implement these solutions into the community and have them live and have them running. Another piece of technology that I had the honor to lead was what I like to call the robot walking school bus. And that's actually the official project name. So the robot walking school bus, the original idea was to encourage people to walk. Pretty simple. More specifically, encourage students to walk to school. And if I was to give you a quick vision of what it looks like, essentially imagine WALL-E. So from the Disney movie WALL-E, that yellow robot with the 2 googly eyes. Imagine him, but imagine him with 6 wheels instead of the 2, and he's got what I like to refer to as these thongs that can help you pick up waste as arms. So you know how like WALL-E's got these hands that look like this, and he can grab stuff. What we've done is we've just taken that WALL-E design. We were very inspired from it. And we made the robot bright yellow, have these big googly eyes, just for fun. This was fun. Instead of using actual hands that we could control with like a remote control or something like that, we just installed some what we in Australia refer to as thongs. So these are like, extendable arms that you can use to pick up street litter and stuff like that.
Okay.
And these were attached to the side of the robot. And the reason why we added that extra thing is because we realized that this robot could have an additional purpose, which is that it could help transport waste from homes to any local community center, such as a school. And that waste could be used for educational material, maybe to provide live demonstrations as to which material goes into which bin, because that's often a confusing thing for certain people, especially for students. It might also be used to collect street litter. So remember those thongs that I mentioned? You could use them to pick up street litter from the side of the road. And the idea, and because of its bright yellow design, again, inspired from Disney's WALL-E robot, it also improves safety on the streets because it's very easily recognizable. And all it does is it just follows a line. Like if you were to look at the technology, it just follows a line. A teacher takes it outside, puts it at the very start of its track, its quote unquote track towards school, and it just follows the line. And students can join along, chat with their friends, and collect some street litter and do all that fun stuff in a very sustainable way. And it makes walking very much safer. The problem that often arises in countries like Australia is that there's this growing sentiment to just drop kids off to school because it's safer, and it's understandable. Parents want to ensure the safety of their kids, and the best way to address that is through having some supervised teacher monitoring the kids as they walk to school. And because of that group environment, it makes it less likely for something to go wrong. So that's kind of the idea, and it doesn't just have to be students; it could be anyone. And thanks to that, and it was actually a team project. Multiple people were involved, while I was leading sort of the back end, the development of the project, we had someone else present it at at the Victorian Design, so the State Design Waste Challenge competition of 2019. She's an excellent storyteller. She's really good at telling stories, and we won the junior. Category for the competition, just because of the fact that this was a student-led project, and the local government was willing to support it. That's the solutions that we're looking for. We're looking for those student-led solutions that the government can back up and support and say, yes, we are here to support you. We are here to provide you with a good future. Nowadays, I've been sort of helping other students and teaching other students, and helping them follow a very, very similar path, but their own unique path. So last year, actually, I had the privilege to be on this committee, this youth committee that set up the first ever Youth Environment Summit, Youth World Environment Day Summit, in our local community. And this was once again supported by the local government. So I feel like, yes, while individuals have a lot of power over, how they can shift and make change in the community, if the government, if the local government or even local businesses get behind it, it automatically raises the bars. It raises that, that level of experience and that level of outcome that you would expect.
The participation of local leaders, and those could comprise of students, the elders, NGOs, local community at large, government. I think it's and private enterprises, small businesses. I think at the end of the day, it's about everybody coming together and finding a solution for all of us.
Yeah. So again, like all these efforts, again, these were team efforts. So it wasn't just a single person knocking it out and getting the project done. So don't think that this was a team. This was just a single person project. But this work eventually got recognized by the state government as well. So the state government invited us to present the robot walking school bus.
I really want to talk more about your love for astronomy, and is this just curiosity or there's more to it?
Whew, that's a bit of a curveball question. I like it. What I find is that when I first got interested in astronomy, the first thing that really blew my mind, for a lot of people, it may just be the pretty pictures, right, of the solar system or of the universe that really got them captivated. For others, it might be one particular show that they watched, maybe by Carl Sagan or someone else. For me, it was actually just a rather weird and goofy video by a channel called PBS Spacetime, very old channel back in 2015 or 2016. So the video was from 2015, but I watched it about when I was during 2016 or early 2017. That video really got me interested because it really blew my mind around what exactly we think of as space and time. So I'll share that fascination with you today. So the fascination for me was this idea that we all think of space and time as these two absolute quantities, right? So these quantities that define our position in space, but and at a particular point in time, which we refer to as the present, right? But what I found was that, number one, space is not absolute, right? Because from my perspective, I might have some device here that's sitting at a particular coordinates in space relative to my position. Relative to your position, I might be sitting thousands of kilometers away, right? So each of our what we call space and time space references are different, and that's codified in Newtonian mechanics. But what Einstein did was he said, time is also not absolute. There is no universal time throughout the universe. Time is also dependent upon the observer. And that's what really blew it for me. Because I thought, how is that even possible? How is it that you can have two different time intervals for different observers? And that's what really got me into astronomy. So following that, I really sort of did a deep dive because before then I only really knew much about the only things that I knew about the universe were there's the solar system, then there's the galaxy, then there's the universe, and that's it. And so then I did a whole deep dive, went into astrophysics, learned some concepts around general relativity, quantum mechanics, the conflicts between the two. And then after that, I got more into sort of more typical astrophysics. So stuff like black holes, stuff like neutron stars. And nowadays, I actually have the privilege to work with very famous world-renowned astronomers from across Australia and even sometimes from other parts of the world on a multitude of projects. And most of them revolve around pulsars, black holes, gravitational waves, fast radio bursts, and more recently I've been getting into galactic dynamics, so understanding the dynamics of galaxies, our galaxy in particular. So that's been very, very, very fun. And I've also had the privilege to make a significant contribution to a research paper. So I'm happy to provide that as well for those who are interested in reading it. So it was a very, very fascinating study that we did.
Tell me something, Rudra. What are some of the most intriguing recent discoveries in astronomy and astrophysics?
All right, so I'll mention a couple in the pulsar and gravitational wave space. So recently, this is last year, recently there was a global effort from a multitude of research teams. So one of them was based in Australia, one of them was based in America, and there were a bunch of others scattered throughout the world. I think there was one in India as well. And essentially, they were using these objects called pulsars, which I mentioned earlier. And these pulsars are essentially these rotating dead stars made entirely of neutron stars. But they produce these beams of light that and you can sort of think of them as lighthouses. So sometimes you'll see a flash, sometimes you won't, and you'll see this periodic flash in the radio spectrum. And that's what each of those flashes are referred to as pulses. We can use these pulses of light because these pulsars are so periodic, they are so extremely precise in terms of how quickly they spin. We can use them kind of like clocks, right? Where each pulse represents a tick. Right? So tick tock, so on and so forth. And with this precise measurement of time using these pulsars, you can also measure extremely long distances very, very, very well. And this is where gravitational waves come in, because with gravitational waves, the only way to detect them is to measure distances extremely precisely, because gravitational waves affect the distances between objects ever so slightly in a correlated manner. And so you can use these pulsars to be able to search for this correlated signal that we refer to as the Hellings and Downs curve. And this is the discovery that astronomers made. They found a possible detection of this Hellings and Downs correlation in their pulsar data over the course of 15 years, which means that they are detecting extremely low frequency, long duration gravitational waves, these very slow ripples in space-time. And these slow ripples could be due to supermassive black holes spiraling inward ever so slowly towards each other. And that is something that really fascinates me. There's been a multitude of other discoveries. If you want, I can go through those as well.
Well, I would love to. And I think we'll probably have a complete section on your pursuit of astronomy. But keeping this podcast right now, I definitely want to talk about climate change and the astronomical observations, because I guess particularly in terms of dome seeing, surface level turbulence, atmospheric water vapor content, and wind-driven halo effect, I think these are some of the places where climate change is affecting astronomical discoveries and observations, correct?
Yes. So in fact, if you go to what we find is that when we're doing ground-based astronomy, so astronomy where we're using telescopes on the ground, a lot of these effects due to climate actually do pop up, and that's something that we need to be aware of. The most obvious one is there's clouds, That's obviously a bummer when you're doing optical astronomy. A lot of these problems that you've mentioned here usually typically apply to optical astronomy. With radio astronomy and other forms of astronomy where the rays or waves of light can actually penetrate through the Earth's atmosphere and make its way to the surface, with those aspects of astronomy, you don't get as much. The main problem that you see with radio astronomy, because that's the area that I've been most exposed to right now, you find that a lot of the problem is actually with satellite communications, with radio, with your mobile data usage. So phone calls, all this stuff can affect your data drastically, and this noise, this radio. RFI, radio frequency interference, right? This interference that's affecting our results is something that needs to be accounted for. And there's a very big push in radio astronomy right now to be able to get rid of this RFI as best as possible while preserving the data. Right? So they want to be able to do this while preserving the data, and that's a very difficult job to do. And so they've been using a lot of different types of algorithms to be able to do this, but in more recent times, they've been incorporating a lot more artificial intelligence to be able to get rid of that RFI as much as possible. In terms of optical astronomy, the way to address all the issues with climate is to actually just point a laser straight up into the sky. And that laser can tell you the amount of turbulence in the air. And you can correct for that in your telescope's mirrors and all the technology that's available to be able to correct for that to get very high resolution images. And that's what you'll see with a lot of modern telescopes. But a better idea is to just go to space. And that's why, even though we had many big ground-based observatories like Mauna Kea, the Very Large Telescope, so on and so forth, we still relied heavily on the Hubble Space Telescope simply because it was in space and you could get very high-resolution images in comparison. So that's just one thing.
And I think there's a lot of work being done in that area,
Yes.
and I clearly see some fascinating readings and observations coming through over time.
So this is why everyone is so excited about people going to the moon, because in theory, you would establish a moon base there, and that moon base could be used for scientific purposes. You could set up a very, very massive telescope on the moon with zero atmosphere, no light pollution, and that would get you very, very crisp, high-quality optical images. And without the problems of satellites interfering as well, because while people say satellites are, fairly dark, they're not noticeable, that's only because our eyes can't see the satellites. But you can see them very, very, very clearly in your optical images, and they produce these very annoying streaks, again, which they have to develop algorithms to get rid of. And this actually, I was recently a part of a conference earlier this year in Australia where they had a multitude of astronomers from different fields talking about something called transients. And they all came down to this one conference. And there was this very interesting talk about the role of satellites in blasting our data. But then they said, instead of discarding that data, we could use it for our own purposes to monitor satellites. So not everything is a lost cause. Sometimes it might actually be useful to record this interference. So there's good and bad, and we need to be, aware of both of them.
Well, on a lighter note, no data goes waste, right?
Exactly.
So, Rudra, great conversation. I do still want to understand, in terms of your academics, what are you pursuing right now?
So as of right now, I'm pursuing a Bachelor of Science at Swinburne University, and I'm doing a major in physics and a minor in higher mathematics. So the reason why I didn't why I didn't choose a lot of the big universities in Melbourne, such as or Australia for that matter, such as the Australian National University and Melbourne University, is that while they do have extremely great bachelor programs, a lot of the expertise when it comes to radio astronomy and the stuff that I'm interested right now lie at Swinburne. So Swinburne's got a lot of those experts in those areas that I'm very, very passionate about right now. ANU is certainly one of the best universities for astronomy in Australia, hands down. But in the area that I'm interested in, Swinburne has got a lot of very great, like really good researchers as well, and they're sort of leading this this organization called OSGRAV, the ARC, so the Australian Research Council Centre for Excellence for Gravitational Wave Discovery, and Swinburne has been leading this organization for quite a while now. So they've been doing amazing research so far in gravitational wave astronomy, pulsar astronomy, FRBs, everything that can be related somehow to gravitational waves. That's what they've been focusing on, and they've also been focusing on a lot of other related fields as well in astronomy, which makes them one of the I would say one of the most open organizations, because they're willing to accept, they're willing to work with students during work experience programs, and all that type of stuff, which is really, really, really fun. But I've known them on a personal level for about. I've known many people in OSGRAV on a personal level for the past 5 to 6 years, and I'm extremely privileged that I've been able to do stuff with them. Even when, they were a little bit hesitant, they still pulled through, and they said, we see this passion in you, and they're trying to work with students right now. So the new vision is to actually work with a lot of students, get them interested in astronomy and all that type of stuff, which is extremely fun as well.
What do you intend to do with your graduate program? Do you intend to pursue physics? I know it's too early to ask for, but I'm sure, knowing you, you would have laid out a path for yourself academically.
Yes.
Do you intend to pursue a research-based career?
Yeah, so research-based career is what I am going for. In Australia, instead of doing a master's in research, we have a shortened pathway called an honours degree. So it's just an extra year that's added to the end of your bachelor's degree. And that's only available for certain eligible students. So the idea is that I complete my bachelor's, do a honours degree, and then from there, you can go straight to a PhD if you do well in your honors and you get selected as a PhD candidate.
All right. I guess as you move to every new level, we're going to continue having podcasts around that with you.
Santosh thinking long term.
I do. When people talk to me and congratulate me and tell me what's your long-term goal, I still sit down, because I truly believe that you have to visualize to actualize. I'm looking at what I'm going to talk about in my 1000th episode. And I also feel that voices matter. Every voice matters, right? And I'm very excited to hear your story. I still wonder how you're able to pull time off, because when I was in my undergrad program, I was also working, not in McDonald's, but at multiple places to pay for my tuition. But I do want to understand from you, apart from all of this, how do you find the time on climate? And I'm sure you do take time out to do other activities, which is, you may only need to share whatever you want to share on the podcast.
So sometimes things can get stressful. So I won't say that it's always been an easy ride. Things can get stressful, things can get overwhelming, but it's just something that you sort of have to overcome. And there have been periods where I sort of just didn't know what I was doing. If you think about it, I didn't know what I was doing. And I was sort of just going by at it every single day. And it's really thanks to my parents that I was able to sort of really, truly find this purpose, if you know what I mean.
Absolutely.
So for example, with climate change, the only reason I got into it was because my parents, my dad just simply wanted me to learn how to code. And then eventually I just found a use case for it, which was in climate change solutions. And that's how that started. With astronomy, the only reason I'm doing research today, and having the privilege to work on research projects is because of the fact that, my parents were there to support me, and to really push me and to really do something that maybe other people haven't had the option to do or haven't really thought about doing. It's really about when people say break the system, they don't mean break the system in an illegal way. Don't do that. They mean break the system in a legal way that allows you to grasp those opportunities that no one else would have actually possibly thought of.
I also feel that when you have the opportunity, the privilege, the support around you, why not go out there? Are your parents both in the field of research?
So my dad is into the field of programming, so he's very much into sort of that aspect, developing a lot of enterprise solutions. So that's kind of fun. And my mum has done a lot of things. She's I feel like she's sort of the support, and my dad's sort of the one who pushes me. So whenever I feel like I'm not really in the right place, or I just don't feel right, or something's not right, my mum's there to support me. And when I feel like I have this motivation to do something, but I've got absolutely no clue where to start, my dad's the one who really pushes me. So it's sort of like this support drive mechanism in this that's really pushed me. And so, yeah, I'm extremely grateful for them.
So we are now at the final segment, which is the rapid fire questions. If you could name a newly discovered planet, what would you name it and why?
Sagan. I would name it Sagan after Carl Sagan.
And why?
Why? He was an excellent science communicator. It's one thing to make the discovery, it's another thing to also be the one to communicate it. So Carl Sagan, great astronomer, great communicator.
If you could design your own spaceship, what features would it have?
I was recently watching a video, space microwave. That would be fun. You warm up your food and you get to eat it instead of having it all packaged and hard and, So just the basic luxuries of being able to eat good, warm food. I'm very much into food.
If you could witness any astronomical event in person, what would it be?
The Betelgeuse explosion. So there's a star called Betelgeuse that's about to explode. No one knows when, but people are saying in the next 30, 40 years. So very realistic chance I would watch it, 100%.
What's the most creative way you've seen someone repurpose or recycle an item?
I've seen, this is a hard one. I've seen people reuse water bottles as like these little cups for plants. That's really hard. I often see people just reducing waste, not actually reusing stuff. But you would have to ask an Italian person. In Australia, Italian elderly people, extremely good. They're extremely good at reusing stuff. Ask them. They're extremely good. I'd recommend Garden Like a Nonno. That's a good book.
If you were in charge of designing a sustainable city, what would be the first feature you would implement?
First feature I'd implement local community gardens, urban farms within buildings. First thing that I would do, because a lot of building space could be used just for that. So you could have, maybe the rooftop being used as a local community garden, reduces that urban heat island effect, produces good produce, and you reduce the carbon emissions from transportation.
What's the wackiest eco-friendly invention you've heard of?
There was this invention of a system that you would dump your waste in, and that waste would somehow get smooshed and transported and converted into these like little blocks. And those blocks would then get picked up by some garbage truck and disposed off somewhere else for recycling or something like that. I just thought it was extremely dumb. I'm sorry. I just thought it was dumb. It wasn't really much recycling or anything involved.
If you could have any animal as a sidekick in your environmental endeavors, which one would you choose and why?
If I had to choose, mythical, if we were going mythical, dragon. It's just cool. Who doesn't like a dragon? If I'm choosing realistic, dog. Especially a golden retriever. Very nice, friendly, and they've always got your back. So just really want some loyal friend.
What's the most surprising thing you've learned about climate change in your studies?
Most surprising thing that I learned is that all of the climate predictions that have been made are true. A lot of people say that's false, but they're actually true. And one more thing, even though in 2020 we experienced so many changes, our carbon emissions only went down by 7%, and that shocked me in 2020.
If you were stranded on a deserted island
Okay.
and you could bring only one sustainable item with you, what would it be?
A sustainable item. It'd be, can I just say like a plant or something like that can grow fruit? Is that possible? Sorry, that's the first thing that came to my mind. It's rapid fire.
What's your go-to response when someone says, but what difference can one person make in saving the planet?
I would say partially true, but also not true. Because if everyone thinks like that, then no one's going to make change. But if everyone thinks that they can make a small difference and they make that small difference, that's enough to make a big difference. Small changes added up together make a big difference. But if no one is able to make that small change because they say, oh, that small change is worth nothing, then no one will make it. No change whatsoever.
If there's one small change everyone could make in their daily lives, what would it be to combat climate change?
One change, public transport. Use more of it. Get cars off the streets and invest heavily in local biodiversity conservation. Those are the three biggest things that I would recommend.
Rudra, an absolute pleasure talking to you. Do you play any music? Do you like music? Do you...
I actually produce my own music. So so some of the videos that I have, I do produce my own music and I use that in some of my videos. You can visit me on SoundCloud, just Rudra Sekhri, and you can just listen or play back some of my music. All types. I've made a lot of lo-fi music. So for anyone who's interested in listening to music for study or work-related purposes, lo-fi is a great genre. I've been making a lot of music around that. But generally also hip-hop as well, if anyone's into hip-hop.
Unfortunately and sadly, lo-fi is not being used for studies of late. So
Understandable. I can understand that. Yeah.
I just realized that you love to read books. And before we wrap up the episode, you've got to recommend me some interesting books for me and for all the listeners out there. And I know you read all kinds of books. So I don't want you to talk about just books around climate and astronomy. I mean, that's welcome. But in general, what's your reading process and what kind of books do you read?
Yeah, so I read a multitude of books. In high school, we often do a lot of literature, which involves taking a book, reading it, and then analyzing what the author's message is throughout the book. And there may be multiple messages. So some books that I would recommend, one book that I would recommend, which I studied in high school personally, and I actually understood the author's message quite easily, was Station 11 by Emily St. John Mandel. Funnily enough, there's actually a reference in the book to today's society, even though it was published in 2014, namely that there would be a global pandemic. The only difference is that 99% of people would get killed in that pandemic. So that was the only difference. And once you start reading the book and you start seeing the comparisons made between the modern world and the world after the pandemic in Station 11, you'll start to see, what the author is really trying to get across and what really makes our society our society. Number two, another really good book that I would recommend is The Future is Faster Than You Think. It's by two authors. I know one of them, his name is, I think it's Steve Kotler or some person whose last name is Kotler. I don't really look at author names, unfortunately. I just read the title, and that's what I reference. So The Future is Faster Than You Think. It talks about sort of the new developments that are happening right now that would affect the future. So that would be stuff like artificial intelligence and so on and so forth. Very good book. And finally, I'll give you my third recommendation, third and final, would be Dark Emu by Bruce Pascoe. And that book is that book sort of provides a new light on Australian Aboriginal culture before British colonialization. And the reason why that's important is because a lot of the stigma that we have around the native Indigenous population, especially in Australia, is that they were a hunter-gatherer group. But this book presents certain evidence, certain certain British accounts that seem to challenge that and portray them as more of a farmer-based society, which I find it very interesting. So agricultural-based society. So yeah, just some recommendations that I have.
I think I really thoroughly enjoyed the conversation as much as I hope you did.
Yes.
We talked about so many things which really mattered for all of us. And I hope and I wish you the very best in your journey. I don't know if I can jump to conclusion and call you a polymath, but you're getting there. Doing a whole bunch of things, and I wish you continued success.
Thank you.
So yeah, that's it from today's episode. This is the first of the 3-part series on climate and sustainability. Rudra Sekhri, a Bachelor of Science graduate, majoring in physics, minoring in mathematics, and with lots and lots of dreams. Thank you again, and there are a couple of more exciting episodes coming up in the climate series. So as always, stay safe, stay healthy.
And thank you for listening to this episode of the Between Us podcast. This podcast was recorded at Manicpod Studios in Chembur, Mumbai. Our sound engineer is Moinak Chakraborty, and our producers are Arnav Dogra and Santosh Kumar. Our associate producer is Samyak Kamble. The video for this episode was processed at Viewfinder's Edit. The Between Us podcast uploads episodes weekly, and we'll see you next time.